How are you, my friends? This is another Calculus 1 solved questions. In this video, we will discuss differentiability and vertical cusp. Let's start directly with question number 1. Discuss the differentiability of this function. F of x is equal to 1 minus fifth root of x squared at x equals 0. So we have to first find the derivative of this function easily. So the derivative will be here 0. Derivative of 1 is 0 minus, by the power rule, minus 2 over 5, x to the power 2 over 5 minus 1. So minus 2 over 5 is there, the coefficient, and here we have minus 3 over 5. So we can write now the derivative f prime of x as minus 2 divided by 5, fifth root of x cubed in the denominator, because this power is negative. Just to mention that this function is continuous everywhere. That means the domain is all real numbers. You can put any value of x in the function itself. Now let's look at the derivative here. If I put f prime of 0, it will be something minus 2 divided by 0, which is undefined. So the function is not differentiable at 0. There is no derivative at 0. Let's check now the limit of the derivative, as we have mentioned in lecture number 9. So the limit of f prime, this is f prime here, as x goes to 0 from the right, which is a positive. From the right here, it's positive. So this x cubed will be positive, fifth root will be positive. There is a minus, so it's minus infinity. Now, if you check the limit of x as goes to 0, from the negative side, so the negative x, cube root will be negative, fifth root also will be negative, negative over negative will be plus infinity. So we see the right and left derivatives do not exist because they are infinities, and not equal also. Plus infinity and minus infinity are not equal. So we can conclude that this function has a cusp at the point 0, 1. X equals 0, put it in the function here, 0. The y here will be 1 from the function itself. So at this point here, the function has a cusp, what we call a cusp. We have explained that in the lecture, and then we will mention it also in a few minutes. Now, this is the vertical cusp. You can check it in lecture number 9. I put here some definitions for the vertical cusp. The easy one to understand is this one. A cusp is a point on the curve. It is a point on the graph where a moving point must reverse direction. As I mentioned before, let me show you now. If you are going this way, see, you are going this way, this way, this way, up. When you reach this point, you cannot continue. You have to reverse direction. That means there is a vertical cusp. Also, you can check it by the limit of f prime as x goes to a from the left or right. One is plus infinity, one is minus infinity. Or one is minus infinity, the other one is plus infinity. Then you have a vertical cusp. Now, question number 2 says, determine whether this function f of x is equal minus 2 plus x to the power 3 over 2 has a vertical tangent at 0, minus 2 and a cusp at 0, minus 2. You have to check. This is a little tricky question. You have to see here that this function is the x to the power 3 over 2. So this is the square root of x cubed. See, when you have a square root, that means x should be positive here. Because see, under the square root here for the function itself, it is continuous from 0 closed until infinity. This is the graph here. See, it should start from 0. Cannot accept any negative values. Let's find the derivative now. Derivative is easy. 0 plus 3 over 2 x to the power 3 over 2 minus 1. 3 over 2 minus 1 is x power half. So now the derivative will be 3 square root of x divided by 2. See, if I put 0, x equals 0, in the derivative f prime of 0, it is defined. It will be 3 square root of 0 divided by 2, which is 0. So the derivative is 0 at x equals 0. So there is no vertical tangent here at 0 minus 2 at this point. And no cusp also. Because the vertical tangent and the cusp, we have to have f prime at x, or that number. It should be plus infinity or minus infinity. Question number 3, same idea. Determine whether this function x to the power 1 over 3 now, so this is cube root of x, has a vertical tangent at 0, 0 and a cusp at 0, 0. Almost the same idea. Now the domain for this function is all real numbers. This is cube root of x. You remember the graph. This is the graph. We have seen it in the algebra course. Let's find the derivative. 1/3 x to the power 1/3 minus 1, x to the power minus 2 over 3. So it will be 1 over 3 cube root of x squared. That is the derivative. Now, if you replace 0 in the derivative, f prime of 0, it is undefined. So now the function is not differentiable at 0. So you have to check. Find the limit of f prime. This is the checking here. Find the limit of f prime as x goes to 0 from the right. So x positive, it will be x squared plus infinity. And also from the left, if you put x negative, see negative values, you will square it. So it will be positive. So it will be also plus infinity. So the right and left derivatives do not exist, both infinities, but they are equal. So if they are equal, then this one has a vertical tangent. See, if you come into the graph here, on the graph to this point, you are not reversing direction, you are continuing. So there is a vertical tangent here. We can draw a vertical tangent at 0, 0, and there is no cusp at the point 0, 0, only vertical tangent. Question number 4, another function to discuss differentiability at the point x equals minus 2. Now, if we look at solution of question number 4, we start by finding the derivative. 1 over 5 x plus 2 to the power 1 over 5 minus 1. Derivative of 4 is 0. So when you simplify the derivative here, it will be 1 over 5, fifth root, x plus 2 to the power 4 in the denominator. So clearly we see if we replace minus 2 here in the derivative, it will be undefined, something over 0. So f prime at minus 2 is undefined, so f is not differentiable at minus 2. So maybe vertical tangent at minus 2, maybe a cusp. We have to check the limit of f prime as x goes to minus 2 from the right and from the left. See, both, you can see here, power 4, that's an even number here. So whatever x negative or positive, when you add to 2 and then take the fourth power here, see, power 4, so that will be positive always, plus infinity and plus infinity. So the right and left derivatives do not exist, but they are equal. So we have a vertical tangent at minus 2 and 4. From where we get to 4, replace minus 2 in the function itself. So minus 2 plus 2, that's a 0. It will be 4. Now, if these limits different, like 1 plus infinity, 1 is minus infinity, or 1 is minus infinity, the other is plus infinity, then the function has a cusp. For more questions on vertical tangent and cusp, you can see the lecture number 9. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.